Among artificial intelligence experts, there are many ongoing debates. One of these, and it's a very heated one, concerns whether large language models like ChatGPT, Gemini, Claude, and DeepSeek already understand the language they use. Some say there is understanding in artificial systems. Others say no, only imitation of understanding. Let's make sense of this. I'm Mario De Caro, I'm a philosopher, and I work on AI ethics. And this is No White Strawberries. An important artificial intelligence scientist, Melanie Mitchell, conducted an interesting survey. She gathered a good group of experts in artificial semantics, language, and artificial systems, and asked them this question. Do LLMs, large language models, understand language? She gave 4 possible answers. Yes, they understand. No, they don't. They mostly understand. They mostly don't understand. The experts split into 4 equally sized groups. One group, 25%, said they do understand. Another 25% said they don't understand. And then the other 2 groups, about 25% said they understand fairly well, and another 25% understand very little. In short, this shows that there is a strong disagreement on this topic. The reason is simple. There are arguments that seem very solid against the idea that LLMs, large language models, understand. But if you analyze them, you find that maybe they're not so solid after all. A typical argument is that of hallucinations. Large language models often say things that are absurd, wrong, or even ridiculous. If you ask who a professor is, large language models may wrongly say he wrote a book he did not. Sure, it gives all the data, the publisher, the year, the title, but the book doesn't exist. Well then, according to some, this proves that large language models do not have the capacity to understand. In truth, however, this is a hasty conclusion. First of all, even human beings misunderstand, have biases, that is, prejudices, false memories. We make things up, we make gross reasoning errors. It happens very frequently. Moreover, in just the last couple of years, the new systems have implemented modes that allow them to improve their performance, to reduce the number of hallucinations. For example, you may have noticed that today, when you ask a large language model a question, there is a reasoning function, that is, there isn't an immediate answer. Instead, there's a careful analysis of the question, which greatly reduces the number of errors. Then there are the so-called neurosymbolic systems, which combine the old artificial intelligence based on logic and knowledge representation, which Ronnie didn't do, with the new approaches. But it wasn't creative, that's the point. This type of artificial intelligence is combined with the new AI systems based on artificial neural networks, and this leads to a significant reduction in the number of hallucinations. There are other systems, such as the so-called RAGs, which stands for Retrieval Augmented Generation, or Internet-Enabled LLMs, which merely access reliable sources, for example, when a question is asked. In other words, they don't treat all the answers they found during training on the net as equally valid. They give preference to reliable sources. As a result, let me show the progress with an example. In 2025, OpenAI released o1, which has a hallucination rate of around 2 to 5%, whereas in 2020, ChatGPT-3 had a rate between 15 and 20%. So in just 5 years, we've reduced errors to less than a third, so there is a lot of progress. Another objection is this. These large language models don't actually understand the real world. They were trained on texts written by humans, but they've never seen the world. If they say that Rome is the capital of Italy, it's not because they've seen Rome or Italy, yet they answer correctly. So, according to some, this proves that they can't have understanding. They do not answer randomly. Their responses are based on extensive data from real-world human texts. So these are texts that implicitly reflect the perceptual, physical, and social knowledge of the humans who wrote them. So it's an indirect knowledge, an indirect understanding of the meaning of words. And then there's the fundamental point. Humans, for the most part, do not have direct access to the semantic counterparts of the words they use in their knowledge. Let me give you an example. If I say that Julius Caesar was killed in 44 BC, I'm saying something that I learned from texts, or I learned from a teacher who had read those texts. Neither I nor the teacher have ever seen Julius Caesar. This is called knowledge by testimony. I know that the capital of Afghanistan is Kabul, but I've never been there. I've read it from reliable sources. Knowledge by testimony. Well, the LLMs generalize this tendency, which is very important, and tells us that most of our knowledge is based on the testimony of others, mostly written testimony. We know Kabul is Afghanistan's capital, even if we've never been there. Others, like Noam Chomsky, the famous linguist, say, look, LLMs don't manipulate words but numbers, so they can't understand meanings. This is true because, as we've said in other podcasts in this series, LLMs operate through tokenizing and debenting, meaning they transform the smallest units of meaning, which can be words or parts thereof. Words are broken down into units, and these minimal units of language are transformed into vectors of real numbers that are, in fact, embedded. These tokens are embedded, so embedding is performed, placing them in a series of semantic relationships with other words. And this is exactly what the neural network does. This is true, but in principle, this is extraordinarily similar to how the human brain works. Neurons too are embedded in an incredible network of connections with other neurons, and they activate or deactivate due to precisely chemical impulses. However, if we were to look for meanings in the brain, in the neurons, we wouldn't find them. Meanings are found only at the level of semantic production when we speak or write texts or words. That is where the phenomenon of understanding occurs. When I hear language at the level of my semantic understanding, I can analyze whether I have understood or not, whether I use language well or not. But if we were to analyze my brain just like artificial neural networks, we would not find the meanings. So, if we accept that meaning in humans should only be sought in the way we use language, in actual linguistic productions, then we must accept the same for LLMs, because for neither us nor artificial systems can understanding be found at the level of neural networks, whether artificial or natural. In general, it seems to me that the greatest philosopher of the 20th century, Ludwig Wittgenstein, was right when he said that understanding is measured by evaluating how language is used. If I use words correctly, if I am understood, if I can handle myself in everyday situations, it means I am using language well. And that is the test to determine whether I understand, not the way my brain works. I ask you to do a little thought experiment. Think about your cousin. Do you have a cousin? If you don't have a cousin, think of a cousin of one of your friends. This cousin, you talk to him and he understands. You notice that he understands. He's smart. He uses the language well, so you attribute understanding to him. All right, now imagine that one day it turns out this cousin wasn't biological, but artificial. He was a product of the MIT Media Lab. Of course, we would no longer say that the cousin was a human being. He was an artificial system, but would we stop saying that he understands? Would we stop saying that he uses language well and therefore has understanding? I believe we shouldn't do that. Because, as Wittgenstein said, nothing is hidden. What matters is not how we are made to determine if we understand, but how we use the rules of language.